here it is. This is my submission for the Hackaday Business Card Challenge in 2024. The main event amongst all this is this business card, which is a circuit board where you can wind your own brushless motor and then experiment with driving it and controlling it. All the components will be on the back side, and motors over here, of course. And then there's some off-board connections here to control other motors. So in this little demo I've got set up here, this is running, the logic is running. This motor is not powered currently. This connection over here is to a power supply. I've isolated the motor side and the logic side, although you can tie them together, but for experimenting I separated them. So if I power up the power supply, not only does this rotor spin because it's connected to activated by these coils, there's an output here which is driving this motor as well. And then here's another brushless motor, tiny little one for drones, and this one will work as well. Try to hold that. So you can see that one spins pretty nicely. The manufactured motors tend to work pretty well with this. I haven't dialed in all the controls for making this motor work, and I think the spacings aren't quite right on this. It's not optimal. In most brushless motors, the coils, there's a lot less space between the coils. This has a lot of space. And the magnets are probably closer together too. But bottom line, it works and it's alive and kicking. I'm going to shut the power off just so the coils don't get too hot right now. But point out some of the other features in all this. So circuit board is all available on my GitHub with this project. There's some 3D printed components. This is the motor support plate on the back side. It's hiding back here, and that's what is supporting a small little 1.5 millimeter shaft. And then up on top is the rotor itself with two little bearings pressed in, one from each side. And then these little 1/8 inch by 1/8 inch magnets pressed into the housing. Just two different rotor designs that I was experimenting with. But that's the point of this, is to be able to experiment with different magnets, different rotor designs, different coils. You can also change how the winding is done. There's generally two kinds of connections for brushless motor windings, the Y or the delta. So if you solder jumper this row here, it's a Y connection for the coils. And if you solder jumper this row, or column I mean, this would be the delta winding. And then everything over here is transistors to do the driving, at Mega 328 PB up here. It is connected and programmed with a FTDI cable, USB. There's a SAO port on it, so it's got some I2C. This is a SAO OLED that I made for another project, or just in general an add-on for stuff like this. And then this project back here is yet another project for some aviation explorers and learning electronics. But one of the goals I had was to be able to make a brushless motor driver that we could learn how to use and then interface that with a propeller and a motor that actually looks like it belongs on an airplane. The construction is relatively simple. Each of these windings, however many winds you want to do, I've experimented with 30, 100 turns, but the way that the circuit board is laid out is you wind each of these coils clockwise, so it's a pretty consistent pattern that you do. Start in the left hole, wind around until you fill this up as much as you want, and then the wire through the right hole. Do that 6 times, solder them in the back, and then it's connected up. I'm using 32 gauge wire. This is a little winder that I made. It's just a 3D printed piece of plastic with a hole through it in the wire, and it allows you to feed the wire in, put some drag on it, but then use this end here to loop around the armatures, I guess. Just to show there isn't too much smoke and mirrors going on here. This is just populated with the transistors and resistors to drive the coils. This whole system operates at 5 volts. This is the open solder jumper right now that separates the power, the motor power from the logic power, which is coming through this FTDI cable. So that's why the battery pack isn't connected. The Atmega 328PB, there's a reverse mount RGB LED there, some simple voltage reverse polarity protection, little power switch there. But my hope is that this will allow me to learn a whole lot more about brushless motors, and then I think other people might be interested in it as well. It could turn into a kit that kind of an all-in-one build your own brushless motor and experiment with driver and firmware techniques to control it. That's all I got. It's time for bed. Good night.